thank you for invitation. And yeah, first greetings from Uma Balakrishnan, the third of our team, the librarian. Unfortunately, she couldn't attend. Yeah, so me and Stefan will give the overview. As already said, coli-conc is an infrastructure, or you could also say it's a project because we got some funding, or it's a free service of the head office of the Common Library Network GBV. So our employer, we are a public service institution for the libraries, and we offer a system for collecting, management, and mapping of knowledge organization systems. And yeah, to summarize, coli-conc provides first the access to the systems and to mappings, then a tool, the tool named Cocoda. That will be the core part or the largest part of our presentation, and you can that's something to see and try out. And we store and provide access to metadata about knowledge organization systems and their content, and the mappings. And it's all free software, and also some tools to convert data integration, and so on. That was we needed to build this to set up all the infrastructure. And under the name coli-conc, this was funded or still funded until next month, since 2015 with a break 1 year. So it's quite mature, the project, and we have something to show. We also have several partners. During the years, we collaborated with several libraries or other institutions, and these are only some of them with their logos. So what was our goal, our objectives? First, we wanted to facilitate sharing of data. So knowledge organization systems are known and used in libraries, but in very specific computer systems, and so we wanted to facilitate it to make it easier. And this was done by establishing and creating standard formats for data exchange. And so we could collect or are collecting data from a lot of systems and connect them to what the outcome could also be seen as the semantic network of, or as the knowledge base. And then the data is used to enhance quality or to create mappings and analyze mappings and do better mappings. And the mappings, the primary goal of the mappings, or what we wanted to do with the mappings, is to do catalog enrichment. And this is mainly done in the K10 Plus Union catalog. The first technical infrastructure, or the general overview. It's a very modular system. So in the center there's a registry, so a database of or several databases of all the vocabularies and all the mappings and annotations and so on. And but these can also be used independently. This component as a database management systems for vocabularies. And then above we have the mapping tool Cocoda. That's the visible editor interface. But the same data is also accessed via this API for other applications. And there are other systems like the user management and so on. Or we have a lot of data sources where we gathered vocabularies and to ingest them into the central store. And this the standard to unify this to facilitate unification of the systems is a data format called JSCOS, and the API that provides JSCOS format is also called JSCOS API. So the core parts is the web application Cocoda that will be shown in a minute, in a moment by my colleague. So this is used for browsing and for editing mappings and concordances. It's all developed in JavaScript and with this Vue framework, and it's open source and also the public development. So you can see our issues and list of bugs or planned features all in a public Git repository, and so you can track when we release new versions and so on. And the backend services, this database management systems, is used in in several databases. So we don't have we have multiple sources of vocabularies. One is called Dante, that's used by colleagues for museum vocabularies, or we have Bartok, the register of the vocabularies with information about it. But we can also connect to other established software such as Scosmos, or we connect or convert MARC XML data and other sources. And then some other backend services to show suggestions and other information. I already said a very important role is this data format. So I will and now this show the components in detail, all this the data formats and the registry, the databases, then the mapping tool, and the enrichment component, and finally how we connect this to cataloging clients. Okay, so first this, the most technical slides, I think, with the data format, the JSCOS data format. There was a need to create something like this because there were several standards, and so we just created another one, but based on existing established methods. So in short, JSCOS is the SCOS data format, or data model SCOS in RDF, expressed in JSON or JSON LD. And so it is also a way of expressing RDF, but we added a lot of additional fields that were missing in SCOS, and the core parts in SCOS, you can express a vocabulary with hierarchies and notations and labels, but we can't express, for instance, who created a mapping and such metadata. Yeah. So we extended it to also represent concordances, so sets of mappings, and the mapping itself, additional information about vocabularies, and some things, details about mapping, such as the confidence level, or where a concept is used in the catalog, and so on. And it's all specified publicly. So it's a JSON format, and I think for web applications this is a de facto standard, and most developers will be pleased to reuse this. Okay, then we have the registry of the vocabularies, and we during the project we switched from our own collection to Bartok, because we took over this register. Bartok, you probably know, and Bartok contains a lot of vocabularies and with information in different languages. And if we want to support one new vocabulary in our mapping tools or on other tools, then we decided that first we enter the information about this vocabulary in Bartok, and Bartok is a source of truth, or the first point to look up information. Also information how is this published, license of vocabularies, and so on. So third, the registry of the concordances. So we have the vocabularies, this is Bartok, and the concordances is the information about mappings. And during the project, we collected several thousands of mappings and concordances, and so we needed some way to organize the information about these concordances. And there's it's also stored in JSCOS format. So the JSCOS format has a special data type for concordances. Yeah, and then the like I said, the most the core application that combines all this APIs and data formats and services is the mapping tool Cocoda. It's we have public or several public instances, one developer instance, one release version, and it can also be installed locally with Docker or other means. So you can just try it out, and Stefan will show give you an overview of the tool in a minute. So I will just skip to the remaining two two parts of our project. First is the enrichment. So when we create a lot or collect mappings, we want to do something with them. Mappings are nice, but yeah, what are they good for? And so the first application is to enrich information in the data in our main library catalog. So these are internal fields. It's speaker format. It's similar to Mark. Yeah, well, you can just ignore. The point is this is the field of to denote this is a DC number. So 549 for mineralogy. And if we have a mapping to BC classification, this BC is used in a lot of German libraries. So BC 38.30 is also mineralogy or subsumes mineralogy. And if we have this mapping, we can automatically create an entry for the BC classification for this book or all books with under mineralogy, and assign fields with a notation from this classification and source information. Especially this comes from project coli-conc, and we put in the URI of the mapping. So if it turns out that this mapping is outdated or wrong, then we can go back to the library catalog and look up all the enrichment and modify and correct it. And so this part of the project is called coli-rich, and there's also more information about it on a dedicated subpage. And this, I skipped the general workflow, how this is done. In the end, it's we look up mappings and look up catalog data, and whether something is not subject indexed, and whether we can derive data and put it into the catalog. Sure, if you know library catalogs and IT, it's the devil is in the details, and it's a bit more complex, but basic idea is not so complicated. Yeah, and finally, the last major application we created, or service we created, is a connection to the cataloging system. So we have several in our library union. We have several cataloging systems, or well, two. The main part is the WinEBV, but it's not the only one, and it's not the newest system, so it looks a little bit outdated. But we managed to get Cocoda integrated into the system, where the catalogers look up the raw data format and do subject indexing. But more and more, the subject indexing by librarians is done with other tools, because for this task you don't need all the details of the cataloging software and all the internal field numbers. And so we have one software called Digital Assistant, or version number 3, DA3. And with this tool, you get suggestions which subject would fit to a book. And this suggestions are also based on mappings among other sources. Okay, so this was a general overview of the project, and I'm sure we will come back to part of it with the questions, or after the whole application has been shown. But it will come more clear and more interesting when you see the Cocoda application. So I give over to Stefan to do this live demo. Just take the screen.
Mm-hmm. Let's see. Okay. Should work, right?
Yep.
Okay, my name is Stefan. I'm the developer of the Cocoda mapping tool and a lot of the other software and services around it. And I'm going to do a live demonstration of the tool. I have to note that I'm using a local installation of the tool, because I wanted to use the English Dewey Decimal classification, and we can't host it publicly. So I have a private installation of the English DDC to use in this presentation. So this is the mapping tool. The basic structure of the tool is that we have on the left side the source vocabulary or source scheme, and on the right side the target scheme, and in the middle is the section for mapping. So the first thing you'll do is you will choose a like vocabularies that you want to map, and for this demonstration I'm going to use the DDC as the source vocabulary. And now we get a lot of information. Here right now we have information about the vocabulary, and there's also the hierarchy. If it's classification, you can browse the hierarchy here and look for the concepts inside that vocabulary that you want to map, or just see information about it. If you choose one, then you get further information about this concepts. In this case, I have German, or what's happening here. The German translations and some metadata and links to other sources, and this I'm going to come to this later. In the middle, we have the mapping element. On the top is the mapping editor, which I will show in a moment when I will create a mapping. Down here we have right now the mapping navigator is open, and this shows mappings that are related to the currently selected concepts. In this case, it's theory or philosophy, and we are seeing here that we have 30 mappings that use this DDC concept, and there's also other sources. We have locally saved mappings in the browser, and also we have an integration with Wikidata, and we can access both the Wikidata entities and also mappings that are saved right in Wikidata, and we can also save them from Cocoda into Wikidata. And down here we have suggestions for the selected concepts, which I will also show in a moment. For the target, you can see here we have 69 vocabularies available. That's just a subset of all the vocabularies that we could access, but we have chosen those that are relevant to our project. But in theory, you could have your own installation that has a different set of vocabularies. And for the target vocabulary, I'm going to choose the thema classification. Up here, we have a search inside the selected vocabulary. And for the mapping example, I'm going to go and map the number theory concept in DDC. So you can search for it. We have several to choose from here. And this is the one I want to map. And now we can see that we have different suggestion modules here. Down here we have catalog co-occurrences. It's not there's some errors in the data, so we have some blanks here, but these are showing when two different concepts from different vocabularies are used together on a lot of different different entries in the catalog, then we can query that here. And we also have suggestions that are based on the text. So in this case, it just shows the number theory concept in thema. So I can access that. And if I want to create a mapping, we have this mapping editor up here. And you can either drag and drop a concept in here to add it to the source side, or just use the plus button here. You can also, instead of constructing the mapping like this, choose the suggestion that we have here and copy it directly, so you don't have to assemble it. In this case, we also want to choose the mapping relation. So is it just a close match? Is it a broader or narrower match? In this case, I would say it's an exact match. So I'm going to choose that. And now I can save it inside the registry. And now here we have the mapping that I just created. So we also have, as Jacobs showed, we have a set of concordances. Concordances are just collections of mappings. They use, like sometimes you have one concordance for a whole mapping between two systems, but if there's if the system is really large, then you have several that for different subsets of a vocabulary. What I want to quickly show is that we can create a new concordance right from the tool. I'm just not going to change anything, but you can add a description and also add other people who can then also create mappings and save them inside this concordance. And now if I go back to our mapping, I have the option here down on the bottom right to choose a concordance, and only those that fit are shown here. So if I can select this and save the mapping, then we have saved the mapping inside the concordance, and now it shows one mapping here. There's also a mapping evaluation system inside Cocoda. It's kind of like a crowdsourced voting system for mappings. You can see the number here, plus minus zeros, just says there's no evaluation here, but anyone who creates an account can upvote or downvote mappings here, and then can give an indication whether that mapping is likely correct or incorrect. And you can also configure certain people to be able to confirm a mapping, which is basically like an override. And we have experts in this topic, and the expert says this is a correct mapping, and then it shows a little check mark. And we recently also added a way to provide feedback without creating an account if you have like detailed feedback or you don't want to create an account. And if you say this is not correct, then you can also give a reason, and we have 4 different reasons here that you can choose to just give an indication why this mapping is not correct, so that the person who created it can correct it. Okay, what I can quickly show is Jacob also talked about the JSCOS format, and there's here we have you can see the details of the mapping that we just created, and we in many places we have this source data icon, and there we can access the JSCOS data of that mapping. So we can see we have from and to. This is these are the concepts that we selected. We have the vocabularies here. We have the creator, that's me, the exact match type, when it was created and modified, identifiers, and a URI that is unique. In this case, this is locally to my system, and also the part of is just notes which concordance is a part of. In this case, it's the one that we just created. And you can also access, like download the mapping or access the API where it comes from. One other interesting thing that I wanted to show is that we also integrated the coli-conc tool, which Jacob hasn't talked about, which analyzes DDC build numbers. So in this case, I've built a number here, and it analyzes the number and shows you the analysis. In this case, we can see that it's this Earth Sciences of Asia, and specifically for the Hokkaido region in Japan. We also have a more complex example here. So you can see there's a lot of parts of this build number, and what this could be useful for is if you have build numbers in your catalog and those don't have a caption attached to it, you could create a mapping for this number by using this data here and see what it maps to in the target system. There's also a separate web interface for the Coli-ana tool that you can use to analyze the VDC numbers, which I will not show today. Yeah, there's like a lot of more smaller things in the interface. You can change the interface a little bit. You can make certain things bigger or smaller, or you can access some settings depending on which component it is. There's like more complicated settings. You can set the results per page, or how often it will refresh it from the server. Yeah, and smaller settings here. And we can also delete the mapping, the delete button here. Yeah. I think this is the base, the basis of the Cocoda mapping tool. Yeah, you can use it to create mappings. Anyone can go to our website and use our tool to start creating mappings, either publicly, or maybe if you just want to try it out, you can save them locally in your browser. They all get saved into the public database. Yeah, and it's freely available for anyone to use. Okay, I think that's it from my side. I'm not sure, Jacob, do you have more slides to present?
We have, I think the remaining slides are just summarize the Cocoda. So at our homepage, our coli-conc, GBBD, at the publication section, the slides from today are already linked, and there are some additional slides with just a bit summarize Cocoda, but a live demo like you have given is I think it's the best.
Yeah, I can maybe also post some direct links in the chat.
Yeah. So feel free to ask questions. I think Stefan showed most of the features. Or if something was too quick, we can give in detail.
Yeah, maybe I was a little bit quick on some things.